Hey all, welcome back to the lab. In this video, we're going to be talking about how to run an F# and Falco web app in a Docker container. So previously, we walked through building a basic web app with F# and Falco. We built a single file web API, and then we turned that into a full stack web app by adding a front end. And so in this post, we'll be adding a Docker container to it to kind of show you or extend the series to make it easier to build these things once and then run anywhere. Now, as a reminder, we'll be going through a lot of code here. I'll be demoing the code, and Technomancer members do get full access to all the project files here on GitHub, along with dozens of other example projects we talk about on the blog. And so if you want access to the full files to be able to get clone and run it, join here. Okay, so why run apps in a Docker container? Why am I even bothering to do this? So I build most of my apps in Docker containers, and I like containers because they allow a relatively simple way to declare your app's dependencies in code. It adds a little bit of complexity on the front end to unlock something approximating build once and run anywhere, that can actually run containers. And in my opinion, this is the closest that we've ever really gotten to an infrastructure as code, build once, run anywhere system. And so that's why I continue to use containers to this day. And so a few benefits it has. It's infrastructure as code to get, close to deterministic builds. You don't have to worry about changing your Python environments or, making sure that your NPM or node is the correct version. Instead, you can just specify all of this in your Docker container, and that will handle it for you. And then so we get these deterministic builds, but we can also run this anywhere Docker is installed, making it easy to share and run code on other machines. And so this is useful for me because I can run it on my machine. I'm running Windows, and then I'm running Whistle, which is Windows subsystem for Linux inside of it, which is a very weird setup that most people do not use. But it doesn't really matter because if I can give out the Docker container, then they can run it on whatever they're running, whether it's Mac or some Linux or Windows or whatever it is. And that's useful for that, but also for deploying to remote machines where, it's very unlikely that that remote machine is going to have the exact same version of Node or whatever it is that I have. But as long as it can run Docker, it can run my code. And this is how I deploy my apps to places like Google Cloud and host on my own VPS with Coolify, which is how I'm doing most of my apps these days. Another benefit of this is, so, a core principle of software engineering is to build composable components, right? Like good software, good systems are really like Legos. They're self-contained, but you can put them together to build something much greater than any one of those things could do by itself. And, theoretically, it's easy to interface throughout the system. Well, if we do that at the code and container level, now all of those are self-contained builds, and we can just configure them together. And so this makes it much easier to, spin up apps on a grander scale. So for example, in a lot of my development and stuff that I do with Cloud Seed, my project boilerplate, I use this as a way to spin up a development database with Postgres and then spin up my container to actually model or be close to what the actual production environment would be like. So when I'm coding, I can minimize the difference between dev and prod. And so yes, this is a bit of extra work to do Docker containers, but I think it does pay dividends long term and is well worth it. Okay, so with that out of the way, let's talk about how to run an app in a Docker container. So the first prerequisite is that, you need Docker installed on your machine or wherever you're going to run this. And there are several official guides for most major operating systems, whether you're running Mac or Windows or, popular Linux flavors. So go over there to do that if you're planning to run this. What this is going to do is allow the machine to actually run the Docker container, and then now all we have to do is actually configure how this container is going to be built and how we're going to want to run it. And so the first important thing is the Docker file, which really specifies how to build and start the specified container. And then Docker Compose, which is allowing additional configuration for multiple containers, like what volumes to use and ports to attach to. Now, I want to note that Docker Compose is not strictly necessary for this example or for running Docker containers, but I personally find it helpful to specify additional runtime information as code, whereas if you're running it just as a Docker container, you would specify those things as command line parameters, which I just find really clunky and annoying to have to copy and paste. And if you're going to be running multiple containers that are going to depend on each other, like it's a local microservices, or again, this is how I do my development database setup when I'm developing locally, then this becomes way better and cleaner in my opinion, because you can do things like specify them to specific ports without having to remember the ordering of things or anything like that. Okay, and so now we'll go through the code walkthrough. And first, let me actually just run this to show you, what we're even doing here. And so here I am in my example projects repo, and I'm in our F# Falco full stack app with Docker project. And what I'm going to do is I'm just going to run my command, which is docker compose down to close any containers that are still running. Then I'm going to do a build, so it builds it, and then I'm going to docker compose up so that it actually runs it. So we're going to do that here. We can see that it built some stuff, and then you get your standard ASP.NET Core output showing that it's actually listening. And this does say 8080, but we'll talk about this in a second. I'm actually mapping the containers port of 8080 to my machine's port of 5001, an example of why it might be useful to use docker compose here. And so if I go here, you'll see something, or my front end for my example app, which is just a simple item count. And then so if we go to /create and create a few of these, and then we go back to root, we see that a few are created. And so if you followed along in the previous post, you'll see that this is the little example app that we've created, and this is running from my Docker container. Okay, so how are we doing this? So let's start off with the Docker file, and you'll see that, we got a few files here. Get ignore, we got our program.fs, it's a single file web app, so very small, and we got our fsproj. Those are really the main things for the app, and then we've got our Docker file and our Docker compose all in the same directory. So the first thing we're going to do is actually build the .NET app, and it's very common with Docker containers to have different layers. You usually install dependencies, then build the app, and then you will actually have a new layer for actually running it, which just helps Docker cache some things. And so we do that here. We start off with a base image, which is going to be .NET SDK 9 because I'm running .NET 9. We're using Bookworm Slim, which is going to be the Slim version of a Linux flavor. I believe this is Ubuntu. And that's the base image that we're going to be building off of. Then what we're basically going to do is we're going to copy in our fsproj and then restore. And so if you're running C# or another flavor of .NET, you change which projects here. And we're doing .NET Restore here to install of our dependencies, and we're trying to do this so that if your code changes but the fsproj doesn't change, then we don't actually need to run the install anymore, which is just a little bit of a caching thing. And then once that's installed, we're going to copy all the rest of the source code in, and then we're going to run .NET Publish, and we're going to output it to a file that we know about because we're then going to reach into there in the next step, and that's going to be copying our builds into here. So we're creating a new image. This is just going to be ASP.NET 9, so we don't need the full SDK, we just need what we need to run. And then we're going to copy from our build layer, which we specified up here, into our work directory, and then we're going to run it with .NET web.dll. And that's basically how we're spinning it up. And so in this way, this Docker file specifies everything you need to actually build from source and then start the web app. And then I have this Docker compose here, which again, probably overkill for our example, but I find it useful. And so you can do a lot of special things with this. So you can declare a bunch of different services. Here we just have one of these, which I should have changed this. This is from my Cloud Seed version. But here we can specify a build folder, which is useful if you have a /source or /app or something where all of your source files are. This is a way that you can specify, how do I build this container from a subdirectory? We give it a container name, which just, uniquely identifies what this container is. This is kind of not this specific instance of the container, but what is the category of container. And then this is how we're specifying our ports. So we're saying, hey, map the machine's port of 5001 to the container's port of 8080, which you can imagine is very useful if you have 5 containers and you want it to be 5001, 5002, 5003, etc. And if you don't do it this way, you are going to have to pass these into your container CLI parameters, which is just annoying. And then you can set up environment variables if you want, connected volumes, which we're not really using any of these, but I'm just here to kind of show you an example of how you might do that. So as always, I've got my summaries here, and then I've got all of the Docker file and Docker compose code here. If you just want to look at it, copy and paste, and if you want to see more examples from how the app itself was built or get the full project files, you can see these in these posts or join Minions and then access the example repo here. And so yeah, that's how I'm running F# and Falco web apps in Docker. If you want to go a step further and see how I build, run, and deploy my F# and Falco web apps to production, and how I start most of my web apps, you can check out Cloud Seed, which is my F# project template, which has that development database container in there. It shows using Docker Compose to build my container and actually depend on it, how they connect to each other, stuff like that. And so if you like this post, you might also like the previous post in the series, the build a single file web API with F# and Falco, and then how to turn that into a full stack web app by adding a front end. And then if you're interested in kind of seeing like how I am using these Docker containers to actually deploy, you might be interested in hosting my Docker container on a VPS with Coolify, using it as a platform as a service, and then using GitHub to do auto deploys, which is basically how I've been hosting a lot of my side projects like 1 million checkboxes and stuff for pretty cheap. So yeah, that's it for this video. Thanks for watching, and I'll see you in the next one.